We're going to talk about half angle identities. And like most of the stuff we've been doing, I want to show you where it comes from. I'll show you how to manipulate some of these previous identities that we have. So we're going to work with the power reducing identity. So sine squared of x is the same as 1 minus the cosine of a 2x divided by a 2, as well as cosine squared of x should equal 1 plus cosine of 2x divided by 2. So here's what we're going to do. We're going to go ahead and figure out the half angle. So if x represents the angle, I need to cut that in half. So I'm going to start with the sine function. So I'm going to say I have sine squared of an x divided by 2. So that should be 1 minus cosine of 2 times an x divided by 2 divided by 2. All right. So I guess I should have put this in parentheses here. Oops. Right. Because that's what's going on inside of the trig function, right? I have the 2 times whatever angle input I was given, and that angle input was a half. So I could say that I currently have sine squared of x divided by 2 should equal 1 minus cosine of x divided by 2. Since my goal is to find the half angle identities, I need to undo that squared that the sign on the left currently has. So if I do the square root, I end up with sine of x divided by 2 should equal plus or minus square root of 1 minus cosine of x divided by 2. And that is one of my half angle identities. Right, so if I see sine of x divided by 2, I can replace it with this. We'll talk about how to handle the plus or minus in a little bit. And it's going to be a callback to something else. So if that's what I did with sine, I'm going to go ahead and try and do the same thing with the cosine. Yeah. So I would know that cosine squared of x divided by 2 would equal pretty much the same thing I just had, except a negative version. So then we get cosine squared of the half angle that was given to me equals 1 plus cosine of x divided by 2. Go ahead and introduce the square root. We get cosine of the x divided by 2 should equal plus or minus 1 plus cosine of x divided by 2. All right. So if you notice, I put the plus or minus, and I put that there because when you take the square root of a value, you should know that the answer could be either positive or it could be negative. We need more information to determine if it should be positive or negative. So that's where we go back and we think about, well, what was the angle given to me, right? What was that x value? X value, right? So for sine, I need to consider the quadrants in which sine is either positive or where sine should be negative. So, you know, since we are dealing with sine, we know sine is positive in either the first or the second quadrant. So if the given angle falls somewhere between the first and the second quadrant, then we would expect our answer we should use a positive version of the square root. If the given angle would fall somewhere, oh, actually, I should be a little more careful. It's not just x. It is actually the x divided by 2. So when you have your given angle, you plug it in for x, you divide it by 2, look at that angle once it simplifies. Figure out the quadrant where that angle is located. If that angle falls in the first or second quadrant, since we're dealing with sine, I would want to use the positive version of the square root. If the x divided by 2 produces an angle that's somewhere in either the third or the fourth quadrant, then we would use the negative version of this. Cosine, similar idea, but cosine is positive in either the first or the first or fourth quadrant. So if I want cosine to be positive, right, I have that positive x divided. If x divided by 2 produces an angle that would either fall in the first or the fourth quadrant, I'm going to use the positive version of this identity. If x divided by 2 produces an angle that would fall in either the second or the third quadrant, then you would just use the negative version of this identity. And since that's what we have for sine and cosine, let's talk about how we're going to do tangent. Okay, so now let's talk about tangent. So for tangent, we don't have a power reducing identity for tangent. So let's think about tangent as sine divided by cosine. So specifically in this instance, it's going to be equal to sine of the given input divided by cosine of that given input, in which case it's x divided by 2. So now all we have to do is use the identities we just found out. You know that sine of x divided by 2 is equal to plus or minus the square root of 1 minus cosine of x divided by 2, as we know that cosine of x divided by 2 is equal to plus or minus the square root of 1 plus cosine of x divided by 2. So we're just going to go ahead and do the substitution. Yeah. So plus minus square root of 1 minus cosine x divided by 2 over plus minus square root of 1 plus cosine of x divided by 2. So now that we have that, since you're dividing a radical by by another radical and the indices are the same, you can just combine that into one giant division sign. So if I do so, here's where we end up. All right. First and foremost, it's still going to be plus or minus because I don't know exactly what the signs are, because in some instances, depending on where x divided by 2 falls, it could be that sine is positive, cosine is negative. So we don't know if that's going to be plus or minus, so we're just going to leave it like that. All right. And now if you notice with my Miami Dolphins colors, the orange and the teal, I'm dividing fractions. So when you divide fractions, you just multiply the numerator by the reciprocal of the denominator. So you could write this as plus or minus square root orange times reciprocal of that. And if you multiply those, you should see that the 2's will eventually cancel out. So this one is equal to plus or minus square root 1 minus cosine of x divided by 1 plus cosine of x. So there's your half angle identity for tangent. All right, so now let's talk about how to actually use these. All right, so let's say we're asked to find cosine of 5 pi over 8. Again, you always have a calculator, or you have a calculator, but I'm going to teach you how to not use it because it's important that you get more comfortable with some of these algebraic operations, because it's the facility with the algebraic operations that's going to be more important in the higher level math classes than just being able to type something in a calculator right now. So that way you can understand how things are going to work out later. Okay, so the first things first is I see I have a 5 pi over 8 as the given angle. The issue is that's not one of my reference angles or even a principal angle that I can work with. So I need to think about which identity would make most sense to use. So 5 pi over 8, I can manipulate it and I can write it out as 5 pi over 8 is the same as 1/2 times 5 pi over 4. So the 1/2 that you see there is your clue that we are going to work with a half angle identity. So if I do this, that means I should be able to set this up and saying this is the same as cosine of 5 pi divided by 5 pi over 4 divided by 2. Just to make it super clear what the x value is. You don't have to do that specific step. That's just for you guys to see where I'm going with this. Should equal, okay. So I'm talking about plus or minus. So I need to think about the given angle. 5 pi over 8. That is a fraction that is bigger than a half, but less than 1. So this is in the second quadrant. As a result, I know that means I'm going to use the negative version of this identity. And so I'm just going to go ahead and plug it in. 1 plus cosine of 5 pi over 4 divided by 2. All right. And 5 pi over 4 has a reference angle of pi over 4, which means I'm looking at a radical 2 over 2. But it's a 5 pi over 4, so it should be in the third quadrant, so that should be negative. So this comes out to negative radical 1 minus radical 2 over 2 divided by 2. Right? And as we are simplifying this, I can say, therefore, that I should still have the negative radical 1 minus. Oh, okay, so I'm going to rewrite it because I just need to work this out. The one I'm going to rewrite as 2 over 2. Radical 2 over 2 over 2. So then that should be equivalent to a negative radical 2 minus radical 2 over 4. Okay. Is this an acceptable answer? See, because my concern is I have a radical inside of a radical, but I don't think I can work around it. The one thing I can do is take the square root of that 4 down here. So I should be able to get negative radical 2 minus radical 2 divided by a 2. And just for clarification, I was able to get that circled 4 right here by taking this and that, because the intermediate step was I factored out a 1/2. Oops. From the numerator, so I thought about it as 1/2 times 2 minus radical 2 divided by 2. And since I have this 1/2 here and I'm dividing by 2, well, I could think about it as the 1/2 2 minus radical 2 divided by 2 means that you're multiplying by the reciprocal, so 1/2, which means I have a 1/4. 2 minus radical 2, which is why I ended up with 2 minus radical 2 over 4 at that step. 2. All right, so it's just being able to do some of these fraction operations a little more fluently makes life easier. I've said that for a while. Hopefully you guys have been good with them. All right, so now let's talk about simplifying stuff using these identities. All right, so now let's say we have this purple equation, or expression, I should say, because it's not set equal to anything. 2 minus sine squared of x divided by 2. And you're asked to simplify this. So, the first thing I notice is that I'm going to work with a half angle identity because the input to the sine squared is an x divided by 2. So I'm going to go ahead and approach this problem by thinking about this as 2 minus a sine of x divided by 2 squared. So that means I have 2 minus plus or minus radical 1 minus cosine of x. Ooh, that did not work out nicely. Cosine of x? Nope. All of this is underneath the radical sign, and it's getting squared. So, luckily, when you square a square root, the operations kind of cancel themselves out. The fact that it was plus or minus means that I don't have to worry about that because since I'm working with real numbers, my answer should always be like a positive version of itself. So then I'll have 2 minus 1 over 1 minus a cosine of x over 2. So I can think about that as 4 over 2 minus 1 minus a cosine of x over 2. Just be careful when you subtract because you should be okay with the 3 because 4 minus 1 is a 3, but you're subtracting a negative cosine of x. So negative negative makes that positive. Common denominator of 2 is there. Yeah, I would say that's about it. I mean, we have numbers. We have a cosine of x. Cosine of x is as simple as it can get. If it was a cosine of a 2x, then I would think about maybe using a double angle identity. If it was a cosine squared, maybe I would consider using a Pythagorean identity. But because it's just cosine of x, I can just leave it like that. If I wanted to, I could think about rewriting the 3, because 3 is just 1 times 3, or 1 plus 1 plus 1. But I don't think that replacing the 3 with stuff that equals 1, because they're going to be Pythagorean identities, would help. So that's how I know that's as far as I'm going to get with this. Tomorrow you will work with some half angle identities, evaluating them like I did, and you're also going to work with simplifying trig expressions using the double angle, the half angle identities, and some power reducing ones. So it's going to be a fun day.